Welcome class to our next video. It is on slope. So this is a brand new topic for you. And we're just going to talk about what slope is and simply how to find it given a few different situations. We have another day devoted to the real meaning behind slope when you have it in an everyday real life situation. But today it's going to be a little bit simplified, and basically slope is the degree at which a line goes up or down, or doesn't go up or down. And we're going to start with 4 ways of explaining what slope is, and actually it's not these 4 at the bottom. This is the 4 ways you can represent slope, or other words for slope. So slope could equal the letter m. So that's how we represent it when it's in an equation. We say m equals, and that means slope equals. So there's one way. It's often described as a rate of change, and we'll definitely be calling it that very often this year. Just like a car goes a certain number of miles per hour, that would be, you can graph that and it looks like a slope. It's a rate of change. And then we also have something called change in y. It can be a little symbol. That symbol is called delta. So change in y over, let me bullet these, over change. Oops. Change in x. And then we have the one that we'll talk about a little bit more today, which is rise over run. So it's a very simplified way of saying change in y over change in x. Alright, so at the bottom you notice there's 4 graphs here, and each one of these lines has a different kind of slope. The first one, and the first 2 is what you'll see most of the time. So the first one, in general, is a positive slope. If you imagine someone trying to climb this, they're really struggling. They're putting a lot of energy, positive energy, into getting up that hill. And you read it from left to right. We never go the other way, because some people say, well, it's negative if you go to the left, but we never go left. Just like in a book, you don't go from right to left. We always go from left to right. So this is positive. This next one, you can imagine, is negative. So that's going downhill. And then we get into these other ones. When it's completely flat, you go nowhere. It's a 0 slope. And we say, if you're skiing, right? If you're skiing on a 0 slope, see if I can draw a skier. No, that's terrible. But if you're skiing on a 0 slope line or a horizontal line, it is 0 fun. 0 fun. And then right here, this has a couple names. It's either no slope, which is different than 0, just no slope, or undefined. And we like to joke that if you were trying to ski down this hill, here's your skier, a little bit scared. No slope, no hope. Because if you try to ski down that hill, there is no hope of you surviving. So that's a little trick we use to remember the difference between those two, because they often get confused. So remember, 0 fun and no slope, no hope. Alright, so we can jump into examples now. And before I get into that though, everything has a slope. So when you're walking around on this floor in your classroom of mine, it is a flat line which has a 0 slope. When you are going up the stairs, you are doing a rise, then a run with your foot. You're raising your foot and then moving it forward. You're raising the other foot and moving it forward. that is a slope. The steeper the stairs are, the higher the slope will be. So if you have a set of normal stairs, we'll call that a slope of 1. You'll see why. If it's really steep stairs, sometimes people have those to like their attic. There's not a lot of room. They would have a much higher slope. And then maybe outside of an office building, there's really flat stairs. Those would have a really small slope. So that's the difference in the slope, but we're going to get specific numbers here. And most of the time we do this with a graphed line. So here are 2 graphed lines. I can see already that this one is positive and that this one is negative. That's good to know because my m, or my slope number, for this one is going to be a positive number, and for this one it's going to be a negative number. That way I won't make that mistake later. So what you do is you try to find a spot on the line where you can see where it hits a coordinate. So this one hits, it looks like right there, and I try to find a couple of them that make sense. It looks like it hits here, here. This is a little bit harder to read, especially if you're looking at your video on a small screen. And then you can take any 2 of those points. I'm going to show you why any 2 could work. And you do how much does it go up and how much does it go to the right. On the other one, I'm going to find some points here. I'm going to say this one, this one. So it looks like every 2. This one, instead of going up, because we don't want to go left, we want to go right. So that means we have to go down and then right. Down and then right. So imagine it's like a video game in Mario when he's going up and down stairs. He always goes to the right. That's his goal. Alright, so let's come back to this positive one. This has a rise of 2 and a run of 1. So remember how in the beginning it said one of the ways is rise over run, just like a fraction. We're going to say 2 over 1. That's the rise, and this is the run. And it's a positive 2 over 1, which could also be written as just plain old 2, because 2 divided by 1 is just 2. But we often like it as a fraction when we're really graphing lines in the future. Now, what if I didn't pick those 2 points? What if the first points I found were this one and this one? Seems like the slope would change, but let's see if it does. So this has a rise of 1, 2, 3, 4, 5, 6, 7, 8, and a run of 1, 2, 3, 4. So that would be a rise of 8 and a run of 4, which, for you dividing experts, is still 2. So it doesn't matter which 2 points you take, the ratio is always the same. It always simplifies to the same number. Alright, over here to the negative one, we have down 1, right 2 to get from point to point. Now, that action of moving down is what made it negative. So I just want to make sure, double check that I put negative, and then it's, oops, I started wrong there. We went down 1, right 2. So it looks like my slope is negative 1/2. Well, okay, again, what if I didn't pick those points? What if I picked this one and this one? I would say down 1, 2, 3, and right 1, 2, 3, 4, 5, 6. And again, that simplifies to negative 1/2. So, like I said, it does not matter which 2 points you take. Okay, so there's another way you can find slope, which is to take, if someone just gives you 2 coordinates. So imagine you had this graph in front of you and they said, hey, how about here and here? And you had to imagine that line that goes through it. Well, you could still do rise over run. That's enough information to get rise over run. But it's a pain in the butt to have to get a graph out and graph the 2 points every time. So some smart people realized that it's just simple formula of let's find the difference in that rising distance. And you do that by taking the 2 y coordinates and subtracting them. And then the run is the opposite. You take the 2 x coordinates and find the difference between them. So the slope formula is a fancier way of saying rise over run. So we're going to practice this here. Number 1 says negative 1, 2, and 0, 5. I like to label them. So my first one is an x, and my second one is a y. That's how all coordinates go, x then y. And then over here is also x and y, but we can't have the same x and y. So what we do is we go in and we say, these are the first ones, and these are the second ones. And that's where those little numbers come from up top that make it look complicated, but it's really not. So if the formula is to do y1 minus y2 over x1 minus x2, then I just need to copy the right numbers in here. y1 is 2, minus y2 is 5. At the bottom, x1 is negative 1, and x2 is 0. And then I just do the subtraction. 2 minus 5 is negative 3. Negative 1, take away nothing, is still negative 1. And the only thing that happens here is that the two negatives cancel, and 3 divided by 1 is 3. And you can leave it over 1 if you want. So pretty simple, pretty straightforward. We're going to do one more, and we'll leave the last one for you. So this is x1, y1, x2, y2. And again, with the formula first. And that equals 4 minus 3. And then negative 2, again, minus nothing. And that is 1 over negative 2. I don't like to leave my negative at the bottom. I don't know why. I like to just bring it out front. So I'm going to make my answer negative 1/2. Alright, and then number 3, you're going to try this one on your own. And for those of you who like to not listen to me, I'm writing it on your own. And then one last thing before we move on. Sometimes those coordinates are given to you in a different form. So in the last example, they just gave you the 2 points you needed to use. But once in a while, you get a table of values. So it'll say like 3, 4, 5, 10, 8, 21, something like that. That's probably not going to make a line, but that's okay. You take any 2 points. Okay, actually I lied. I want to make it really aligned, so I'm going to change the numbers around a bit. Sorry if you wrote in pen. So I can take any 2 of these points that I want to. And sometimes if there's negatives, I avoid those just in case I might make a mistake. But for the most part, any 2 will do. So I'm going to take the first 2 here, and this increases by 4. So I'm kind of choosing this as my x1, this as my y1, this as my x2, this as my y2, but I'm doing it in a slightly easier way. So notice I am first doing the difference between y1 and y2, just like the slope formula says, and that is an increase of 4. And then I'm going to do the difference between x1 and x2, and that is an increase of 2. So it would be the y1 minus y2 part on top is 4. Actually, I'm kind of doing y2 minus y1 this time, but that's okay. Over 2. And that's a slope of 2. Let's look at what happens if I choose different points. I use a different color. So what if I wanted to use these 2 and these 2 this time? So now I go like this, and I say, oh, there's an increase there of 10. And then the x side, there's an increase of 5. So I come over here and I write my change in y, or my rise, whatever you want to call it, 10 over 5. This is the change in y. This is the change in x. And it gives me 2 for my slope. Alright, so basically that's the same as using the slope formula, but I just showed you in a slightly easier way. And that's as far as we're going to go. We're just talking about how to find slope given some information. We'll get into actually graphing lines next time, and then after that we're going to talk about slope in very different ways, often with word problems. Alright, so good luck. Do that problem on your own, don't forget, and we'll see you tomorrow.